So today we'll be doing add two numbers. What I like to do with these kind of problems is essentially break them down into the parts of the code that I'll be executing against. So we're going to have the initialization, then we're going to have the main body of the function, and then we're going to have essentially any wrap up that we need to do, and then at the end we're going to have the return of the function. Now there's not much error handling we're going to need to do here. We're going to have to be careful of undefined, but obviously both of the lists are going to be non-empty, so we can assume that at the very beginning. However, we're going to have to make sure that we take into account things like different length of the linked lists while we are making the solution. All right, let's start with the initialization. So what we want to have here is essentially the beginning of the list. That'll be the thing that we're returning at the end, and we'll call it return list, or we can call it just beginning, but this is fine, which is going to be a new list node without anything assigned to it. So we have a value and the next element, which is another node of the linked list, but this is just going to be the return list we're going to be using. And at the end, we're just going to return this linked list. What we are looking to do inside the main body is we need some sort of a loop to go around the different linked lists. Now we're going to have to go through them at the same time to make sure we get log n time. And to do that, we can use a while loop. We'll create a new variable that we'll call keep looping for simplicity. That's going to be equal, it's going to be true. And then we're going to have a while loop that will just basically use the keep looping thing, and it will just essentially loop us through the main body of the function. Now what we need to do in the main body of the function is, this is also what I'd like to break down a little bit, is, so first of all, we need to get the values. Then we need to add up the values. We need to move to the next elements of the linked lists, and at the same time we're going to have to move the existing list to the next node as well. So it's not just the ones that we have given, but also the one that we currently have. All right, let's get started with the values. So if we have to be checking for undefined here, make sure that the list that we are getting are not undefined. Const value list 1. This is a terrible name, but let's go with it. That should be equals, if L1 is not undefined, then we can use L1.value, else we're going to use 0. And we're going to use 0 because if L1 is undefined, there's no value available for this, which means we're going to default to 0 because additions here are not going to make a difference with the 0. And we're going to do the same for the second list. If L2 is undefined, L2 value. If not, we're going to be using a 0. Okay, cool. So now we have these guys initialized. Let's do this for the values. So we have a value, which we're going to do a var because we're going to have to change it a little bit later. Current value, and this is going to be essentially the addition of the two. So it's going to be val list 1 plus val list 2. However, what we need to make sure we have is a carry, because we can have additions that are greater than 10, and we're going to have to take that into account. Now that carry we're going to initialize outside of the loop, because we're going to have to use it throughout the loop continuously. So our carry, we're going to initialize it to 0, and we also going to add this to the list. Now this is going to give us the current value. What we need to do now is make sure that we check if we have carry. And how we're going to do this is essentially if it's bigger than 10, that means we have a carry. So very simple if statement. If current value is greater than 9, that means we have a carry, else we don't have a carry, and we can initialize the carry to 0. So if we don't have a carry, we want to make sure that we reset the value of the carry. So we don't take it into account later on when we are actually adding the numbers. And the current value is also something we want to change because we cannot start more than 9 inside one of the nodes. So we're going to reassign that to be essentially current value minus 10. So this is essentially greater than 10 check. And we can do this greater than 10, less than 10. That's it. Now, if we have greater than 10, we're going to also have a carry. So the carry needs to be initialized in here, which is going to be, and carry is going to be equal 1. And we're going to have to make sure that we keep a reference to the beginning of the list. So that's the thing that we're going to be returning, meaning that we actually do need to make a copy of this pointer. And this is going to be const. We are not changing it, but this one we're going to change. This is going to be our iterator list, or rather iterator node equals return list. So that will use the same essential the same pointer. And whenever we change it, that's not going to change our return list. So we are always going to return the beginning of the list itself, but we're going to be changing the iteration node, which means that we will be able to actually build up the list as we go. Now at that point, we're going to be assigning the values. So we have one more operation, and this is assign value, and this is going to be iteration node. What we want to do with it, we want to set the value to be equal to the current value, right? And that's going to set it. But now we also need to move to the next element. Now, before we move to the next element, we're going to have to make sure we have a next element. So what we need to make sure also is we assign the keep looping variable. Let's do this here. So keep looping is going to be equal to if list1 is undefined and list2 is undefined, then what we're going to have is false, else it's going to be true. So if both of the lists are undefined, then we stop looping. But if one of them is not undefined, then we're going to keep going. Now, you can probably simplify this statement a little bit, but I want to make sure it's readable. That's the reason why I write it this way. So after we've set this, we need to move the iterator node forward. And iterator node is now going to be equal if keep looping is true, new list node, which is going to be empty, or if it's not, we're going to set it to undefined. Actually, this is next. And then iteration node also equals iteration node dot next. This is the way that we iterate over it. So that's how we move to the next element. Create next node and move on to it. We got some wrap up to do as well, because if things worked, we're going to have this carry to take into account, which means this can be non-zero at the point that keep looping starts. So what we need to make sure is that if carry is greater than 0, now what we need to make sure is that we create another node. Dot value equals carry. That's what we want to do here. So make sure that this is actually set, but we don't want to unset this to undefined. So we're going to actually use an if statement here. So if keep looping, then iterator node equals, don't need this. Okay, so we create the next, and we set the next node here as well. All right, let's give it a go. It failed. All right. Oh, maybe we should have checked our code before that. Right, what is this equal doing here? Whoops. So we exceeded the time limit, which, to be fair with you, means we just keep iterating and not really setting this properly. Oh, now what we didn't actually do is move to the next element, so that keeps going in an infinite loop, which makes a lot of sense. So let's just keep setting these guys. So if F1 should be equals F1, F1.next, but only if N1 is undefined, then we do F1.next, otherwise just do undefined, which is a no-op, but should be simple enough. And we can do the same thing with L2. All right, that should do it. So we failed, we said the wrong answer. We said a 0 at the end. So that means that we did not do this properly, and we applied the carry at the end where we shouldn't have. Oh, okay. We need to move before we check. And this is the problem. Huh. So that passed, but we had one less 0. What did you do? Okay, so after some looking, we didn't actually create a new node here, we just override the existing one. And what we actually need to do is move to the next node. All right, so we did do it at the end. It took us a little bit longer than I expected, but there you go. We've got this accepted, and now you can look at the various metrics here. So we have our solution somewhere at the top of the bell curve, which is about average, I suppose, which isn't bad given that it's fairly readable code. I think this isn't a bad thing at all. All right, well, thank you very much for watching, and I'll see you soon.